Or you think you'll be okay?
No, I think I can do it. I think.
Okay. All right. So what is a relation? A relation is a set of ordered pairs. Okay. Now, this whole day today, I want you to think of things in terms of relationships. Okay. Like for real, like a relationship, like a relationship. Okay. Like when I think of relationship, like girlfriend, boyfriend. Okay. So a relationship. A relation is a set of ordered pairs. So if we know a relation, or what an ordered pair is, an ordered pair is an X and a Y together, okay? So I want you to think of X and Y being in a relationship, okay? So a set of ordered pairs would just be multiple X and Y's together, okay? So hopefully we understand, hopefully we're at this point comfortable with ordered pairs. Like if I told you to plot 1, 2, and 5, 6, and 7, 8, you would be able to plot those just fine, okay? So a relation is just a set of ordered pairs. A relation is just a set of ordered pairs. So everything we do this year is a relation. Everything is a relation. The question today is that relation a function? Okay, so everything we've done this year is a relation. Every graph we've seen, every table, every word problem, those are all relations. The question now is, are those relations functions? So this machine or this concept, you should have been doing this since elementary school. You input something and some output comes out. Our input is referred to as X. So when I say the word input, everyone should think of X, X. When I say output, you should think of Y, okay? So when I input an X value into a relation, an output value comes out. Input, output. So when I say the word input, you should think of X, the variable X. When I say output, you should think of the variable Y. Input X, output Y. So let's say I had this equation right here. This is just a made up equation. Y equals X plus 5. And I had the input value of 5. What does input mean again? X. So let's say I had the input value of the X value 5. And this is my equation. How would I get its respective output value? Using this equation. Perfect, by adding 5. So I'm going to input X as 5. So Y equals 5 plus 5. And that would give me an output of 10. Right? Everyone making sense so far? If my input value was -2, what would my output value be? 3. Because if I input -2 for X, -2 plus 5 is 3. If my input value was -1/2, what would my output value be? Perfect, 4.5. Okay, so think about that. Every input we put in gave us an output. Okay, I don't need you to write this down, I just need you to conceptually think about this. Every input value we put in, it gave us some output value. Does that make sense what I'm saying? Okay. So here's the question. Is it possible to have multiple outputs for one input? So don't answer it, just think. Is it possible to have multiple outputs for one input? Meaning if I go back here, when I inputted a value, did it only give me one output, or could 5 have given me multiple outputs? What do y'all think? One output, right? When I put in 5, 5 plus 5 equals 10. It can't equal anything else. 5 plus 5 gave me 10. So this one input value only could give me one output value. This input value of -2 only gave me one output value. This input value of -1/2 only gave me one output value of 4.5. That brings us to our definition of a function. This is what we're going to be working with all day. This is what you need to solidify in your brain. A function is a special relationship where every input value, x, has exactly one unique output value, y. A function is a special relationship where every input value, x, has exactly one output value, y. A function is a special relationship where every input value, x, has exactly one output value. So every x gives me one y. Every x gives me one y. Every x gives me one y. So this is how I like to think about it. X is faithful. X isn't a cheater. X is faithful. X has only one y value. For the relationship to function between x and y, x has to be faithful.
I mean, why would X be with Y? X wasn't going to be faithful.
Huh?
Think about it. If X was going with Y, why wouldn't X be faithful? Apparently, like, it's someone you like. I just don't get people who cheat. I just don't get it.
Well, that's unfortunately a problem. But for a function, for this relationship between x and y to function, x has to be faithful. Notice I keep saying x. Only x has to be faithful. X can only have one y. All right, we're gonna look at this video. If it disturbs you, I'm sorry. I think it's quite interesting. All right, go back. Go back. All right, there we go. So I apologize in advance if this disturbs anybody.
Yeah, but why they have to show that part?
No, you can have it back. not going to watch the whole thing. But what that should have shown you is every input only has one output. Okay. And I do have some people every year who that video does disturb a little bit. So again, my apologies. All right.
Unfortunate.
So I don't know if that would make you think differently about eating meat, but there you go. So first thing we're going to do is look at mappings. And we want to figure out if a mapping is a function or not. So go ahead and draw this. Okay, you're going to draw a lot of examples on your paper, so don't try to be a perfectionist. Okay, so go ahead and draw this with all the beautiful arrows coming out of it. Okay, this is called a mapping. A mapping. So when you see a mapping, the first circle is always an X, all the X values, and the second circle is always the Y values, okay? So I'm gonna rewrite the definition of a function. What we're trying to figure out is if this mapping is a function. And remember, the definition of function is every X has one Y value. Every X has one Y value. That's the definition of a function. So let's look at 5. What is the Y value that is associated with 5? 6. So 5 only has one Y value, 6. What is the Y value associated with 7? 4. So that only has one Y value, right? 9, what's the Y value associated with 9? 8. So that's only one Y value. And what's the Y value associated with 11? So based on this definition, does every X only have one Y? Yes. So this is a function. And this is literally the only question we're asking all day today. Is it a function, yes or no? So this is a function because every X only has one Y value. Okay, you ready for the next one? So let's look at this one. All right. So the definition, every X has one Y value. So do y'all think this is the function? Yes or no? Remember, X is faithful. X has to be the faithful one. Does X have only one Y value? Yes.
Nope.
Right? 5 is with 6. 7 is with 12. 9 is with 8. 11 is with 12. Though they're sharing the same y value, doesn't matter. Every x only has one arrow coming out of it. Every x only has one y. So yes, this is a function. So every x is still faithful. Every x has only one y. Now, if y is cheating, it don't matter. Okay? We're only looking at the x, only looking at the x value, the input value. I would say this is the last one y'all have to draw. This is the last one. You just want a couple good examples. All right. Is this a function? Why not?
No. X cheating.
Perfect. So which x is the reason why? 5. So this 5 has two y values, 6 and 8. So every x does not have one y. So this is not a function. Not a function.
X got a side chick.
Yeah, x ain't faithful. So does this make sense so far? It's really not supposed to be complicated. Okay. So the next one you don't have to write down. The next one you do not have to write down. So just look at it, and then I'm gonna give you about 10 seconds. Think about it. Okay, this is just showing that 5 has two y's. All right. So think about the definition of a function. Just think. Don't have to write this one down. Remember, a function, every x has one y. All right, is this a function? Yes. Every x only has one y. Even if they're all sharing the same y, they all have one y. Okay? Do we feel confident with mapping? All right. Let's look at this table now. Go ahead and write this table down. I don't even think I have the right Nearpod on. Oh well. Let me see real quick. Sorry. Bless you. Sorry. I'm trying to see something real quick. Yeah, this isn't even the right Nearpod. Oh well. Okay. So in this table, we want to see if this is a function. We're trying to see, does every x have one y? So when I'm looking at a table, I can do two things here. I can make a mapping. So my x values are -1 and 5. -1 and 5. So I could, right? Okay, -1, -5. I mean, -1 and +5. Excuse me. And I can do the same thing for y. I have -2, -6, -3, -7. -2, -6, -3, -7. And -1 is with -2. And I have a -1 that is with -3. So automatically we should already notice that this is not a function, right? Because these x's have two y's. Or instead of having to go through the whole step of making a mapping, if you notice your x values are repeating, so -1 and a -1, you already know automatically it's not a function because -1 is with -2 and -1 is with -3. Same thing with 5. 5 is with -6 and 5 is with -7. So anytime your x's repeat, you know that this is not a function. Anytime your x's repeat, you know that this is not a function. Okay, ask me questions because I'm done with tables. No? We're good? Okay. Yes. Thank you for asking that. So she said, on the y side, if the numbers repeat, is that okay? Yes, because remember, it's only if the x, every x can only have one y. But the y's are sharing an x, that's fine. It's only the x's though. Okay, so that's just showing what I just said. All right, you don't have to write this one down. Just look at it. All right, in the chat, write down if you think it's a function, yes or no. So just either write yes or no, write yes or no, write yes or no. All right, in the classroom, what y'all think? Yes, perfect. In the chat, good job. Okay, awesome. Because every x has one y. If I was to make a mapping of this, 0, 10, 20, 30, and the only y value is 5, all of them are going to the same y, but every x has one arrow coming out of it. Every x has one y. All right, let's look at another one. In the chat, write yes or no. In the chat, write yes or no. All right, in the classroom, what y'all think? Why not? Beautiful. This one has two y values. One is with 10 and one is with 2. Awesome. Okay. All right. So last thing is the graph. Last thing is a graph. So whenever you're doing notes, don't do the most. Don't try to draw all the lines. Just quickly do this. X-axis, y-axis, line. Okay, so don't try to do the most here. So when we're looking at graphs and we're trying to figure out if it's a function or not, we could go through each value. Oh, 1, 1, 2, 2, 3, 3. And I could keep going and keep going and keep going on this 0, 0. And what I'll notice is every x does have one y value. Or I could do something called the vertical line test. Go ahead and write that word down because you're going to be tested on that. Vertical line test. Vertical line test. Vertical line test. Vertical line test. The vertical line test says this. If I draw a vertical line anywhere on my graph, so anywhere, I'm drawing multiple vertical lines. And if it only hits my graph one time, it's only hitting it one time. It's only going through that green line once. That means it's a function. So if it hits it one time, then it's a function. If it hits it more than one time, then it's not a function. So if I put a vertical line through it, it only hits it once, bam, one time. Anywhere I put it, bam, only hits it once. Bam, only hits it once. Then it's a function. But if I draw a vertical line and it hits it more than once, then it's not a function. All right, let's look at another graph. Okay, if I draw vertical lines through this one, you don't have to draw this one. When I draw vertical lines through it, how many times does it hit it? Once, right? I draw it, hits the green, oh, one time. I draw another vertical line, hit the green, oh, one time. It only hits it once. So is this a function? Yes. So this is a function because it passes the vertical line test. Do I have any questions about that? Okay. Let's look at this one. Is it a function? No, right? Because if I put a vertical line through this, bam, 1, 2, it hits it twice. So therefore it's not a function. Okay. Now, here's my question. This is going to help you on the quiz that we're about to have. Not the quiz, just the assignment for today. If this is my graph and I had a vertical line, this is the graph. My graph is the vertical line. Is a vertical line a function? What do you think? So let's say that this point was at 5, 0. This point was at 5, 1. This point was at 5, 2. This point's at 5, negative 1. This point's at 5, negative 2. Is that a function? No, right? Because all these x's have all these same y's. So if I put a vertical line on top of this vertical line, it hits it like 1,000 times, forever. It hits it at every point. So this is not a function. All right, we're sure there's no questions. So what we're gonna do, let me hide student names, is there's a 20-question assignment. I don't care if we work together. Well, I can't see the questions. It won't show me. Well, unless I press them. Oh, well, that showed you the answer. LOL. Okay, so no, I can't do it with you. Okay, but if y'all want to unmute and help each other, or in the classroom, just do it together.